This video is example problem number 3 involving circular motion and universal gravity, part of orbital mechanics. Okay, so the question is, what is the velocity of the Earth as it travels around the Sun? So first thing I'm going to do is I'm going to look at my table of givens that you're always given for every problem, and I'm going to look at it, and since I'm talking about the Earth going around the Sun, I'm going to make sure I include the orbit. That's going to be the distance between the center of the Earth and the center of the Sun, and it'd be helpful if I had the mass of the object that I'm orbiting, which would be the Sun, and that I have over here. So I'm going to add those to my list of givens. So here's the list of givens that I know so far. I've got my universal gravitational constant and the radius, which is the orbital distance between the Earth and the Sun, the center of the Sun to the center of the Earth, and the mass of the Sun. And this is going to be the strategy. I'm going to set the centripetal force equal to universal gravity, because I know that because it's going in a circle, there's a centripetal force, and the source of the force is universal gravity. I'm going to get the givens from the solar system data table that I already have on the left, and for the centripetal acceleration formula, I'm going to use the one with r and the velocity in it, and I'm going to use algebra to solve for the velocity. Now I know I'm going to use the velocity because it asks me about the velocity, and r is in my list of givens, and that's always going to be in our table. So as I said, I'll start with the fact of the force of gravity equaling the centripetal force. So the force of gravity is equal to m times ac. Substitute in my equations, so I've got g, mass of the Sun, mass of the Earth, over r squared, equals, and I used v squared over r times the mass of the Earth. Now I had a lot of choices. I have these three choices between which equation to use. And when I'm looking at the problem, I can see that I have the velocity, that's what I want, and I have the radius in my givens. So I chose the formula with those two variables. Now moving on, I'm going to have the mass of the Earth divided out of both sides, and that's almost always the case. The mass of the satellite goes away. And I'll solve it for the velocity. So I solved it for the velocity. Notice that one of the r's actually divides out. Next thing all I'm going to do is put in my numbers and units. Making sure when you do this on the calculator, you use that double E key. Don't use the 10 caret symbol or anything special or cute, but use that double E key. And then I'll solve this for the tangential velocity. When I do that, I get 29,800 meters per second.